Students, today our topic is order of reaction. In order to understand the order of the reaction, we must know rate, law, expression. तो ऑर्डर ऑफ द रिएक्शन अंडरस्टैंड करने के लिए ज़रूरी है कि हमें रेट लॉ एक्सप्रेशन मालूम होनी चाहिए. तो इससे पहले कि मैं एक्सप्लेन करूँ, फर्स्ट आई विल राइट द डेफिनेशन ऑफ द ऑर्डर ऑफ द रिएक्शन. सो it may be defined as sum of powers to which the concentration terms are raised in the rate law expression to express the observed rate of reaction, or simply sum of powers of all the concentration terms in the rate law expression is called order of the reaction. तो हम ऑर्डर ऑफ द रिएक्शन ऐसे डिफाइन करते हैं कि रेट लॉ एक्सप्रेशन वी हैव टू कीप इन द माइंड कि एक रिएक्शन को हम कैसे रेट लॉ एक्सप्रेशन करते हैं, लिखते हैं. सो फॉर ए जनरल रिएक्शन AA plus BB gives the product. If rate of reaction is equal to K, so according to the rate law expression, we will write the rate law expression. For the rate law expression is that rate is equal to K, the concentration term of the reactant A raised to power alpha, B raised to power beta. Then order of reaction denoted by N is equal to alpha plus beta, where alpha and beta are orders with respect to reactants A and B respectively. Now we will explain this order of the reaction. Suppose we have a general reaction AA plus BB gives the product, and according to the rate law expression we will write the rate of this reaction which is proved, which is observed experimentally, that it is equal to K A raised power alpha B raised power beta, where K is the rate constant, A is the concentration terms alpha and beta, or the concentration terms which determine the rate of reaction. This alpha, it may or may not be equal to the quotient of A, that is A, and similarly beta, it may or may not be equal to B, the quotient of the reactant B. तो कैसे हम order of the reaction define करते हैं? The sum of the powers. We have power in the rate law expression. We have alpha raised to power the reactant A, molar concentration of A, and we have beta raised to power the molar concentration term of B. The sum of powers, that means alpha plus beta, to which the concentration terms are raised or in the exponent form, sum of the powers in the rate law expression. This is the rate law expression to express the observed, this is the observed rate of reaction that we write by the rate law expression. So the sum of the powers, that is alpha plus beta, this alpha plus beta will give us the order of the reaction. So yeah, simply if we write the rate law expression, that is rate is equal to K A raised power alpha B raised power beta, the sum of powers of all the concentration terms. Here we have only two concentration terms. Had it been AA plus BB plus CC, then A raised power alpha, B raised power beta, C raised power, we can have gamma, and for gamma that may or may not be equal to C, the quotient of the reactant C, which may or may not be equal to C. But here we have two reactants, so it is A raised power alpha, B raised power beta. The sum of the powers of all the concentration terms, sum of the powers is alpha plus beta. In the rate law expression is defined in the order of the reaction. Now, depending upon whether n or alpha plus beta is equal to 0, 1, 2, 3, order of the reaction will be depending upon whether alpha plus beta is equal to 0, 1, 2 and 3, the reactions are said to be the reactions are said to be of zero order, first order, second order, or third order respectively. So we can determine the order of the reaction that will depend upon the values of the alpha plus beta. If alpha plus beta is equal to 0, the reaction is of 0 order. If it is equal to 1, it is the first order reaction. If it is 2, second order reaction. If alpha plus beta is 3, then it is third order reaction. we can have a reaction can even be of fractional order in which the value of the alpha plus beta is fraction. So this was all about order of the reactions. Now we will take the examples of the order of the reactions separately. Examples of the reactions of the different orders. Examples of reactions of different orders. First order action. First we will define it again. A reaction is said to be of first order if its rate depends upon the concentration of one reacting species, e.g. So a reaction is said to be of first order if its rate depends upon the concentration of one reacting species. For example, dissociation of N2O5. N2O5 dissociates and it forms NO2 plus, and rate law expression is rate is equal to K N2O5. Here we have only one reacting species, that is N2O5, and in the rate law expression it is K into molar concentration of the N2O5. यहाँ पावर पर हम जब हम कुछ नहीं लिखते हैं, that means it is 1. So this is the value of alpha plus beta. Beta is here 0 because only one reacting species, so the alpha is 1. So the alpha plus beta is equal to 1. Therefore it is the example of the first order reaction. और second हम लिखेंगे decomposition of H2O2, hydrogen peroxide, it decomposes, it forms H2O2, decomposes, it forms H2O plus 1/2 of O2, and according to the rate law expression, rate we will write is equal to K H2O2. इसका पावर कुछ नहीं है, that means 1. The value of alpha plus beta is equal to 1. Here alpha is 1, beta is 0. So it is the example of the first order reaction. So number second is second order reaction. A reaction is said to be of second order if its rate depends upon the concentration of two reacting species, same or different. तो सेकंड ऑर्डर रिएक्शन हम ऐसे डिफाइन करते हैं, reaction is said to be of second order if its rate depends upon the concentration of two reacting species, same or different. For example, decomposition of or dissociation of hydrogen iodide. Hi decomposes, it forms H2 plus I2, hydrogen and iodine, and according to the rate law expression, the rate of the reaction is equal to rate is K H I raised to power 2. Here the value of alpha plus beta, beta is only one reacting species, two concentration terms, so the value of alpha is 2, so alpha plus beta is here equal to 2, so this is the example of the second order reaction. Or again we will take few more examples of the second order reaction. A reaction between NO and O3. So NO plus O3 gives NO2 plus O2. Again, this is the according to the rate law expression, a rate is equal to K and O3. Here the power of NO is 1, the power of O3 is 1. The value of alpha is 1, the value of beta is 1, so the order of the reaction is 1 plus 1, that is 2, so order of the reaction is alpha plus beta, that is 1 plus 1 is equal to 2. So this is the example of the second order reaction. Or combination of NO and F2, NO2 and F2. NO2 and F2, they react and they form twice NO2F. So the order according to the rate law expression, rate is equal to K NO2 raised power 1 F2 raised power, this is nitrile fluoride. So this is very important reaction. Here the value of A, just like we write A plus B gives the product, and the rate is equal to K A raised power alpha, B raised power beta. B may be same or different to B, the coefficient of B. Similarly, the alpha, it may be same or different to the A, the coefficient of the reactant A. Here, the value of alpha is 1, where the value of small a, the coefficient of the reactant NO2 is 2. So the value of alpha is different from the value of the small a. Here the value of beta is same as the value of B. So it is not, it has been proved experimentally. The experimentally observed according to the rate law expression is that it is not, it should be as per the balanced equation, it should be of third order, but practically it has been proved that it has been observed that it is the example of second order reaction, because alpha is 1, beta is 1, so alpha plus beta is equal to 2. So this is the example of the second order reaction. Now we will take third order reaction. Reaction of third order. A reaction definition similar, just like the reaction of the second order. Reaction is said to be of third order. A reaction is said to be of third order if its rate depends upon the concentration of three reacting species. Example: combination of NO and Cl2. NO and Cl2, they combine this nitric oxide and chlorine and they form twice NOCl, nitrosyl chloride. And according to the rate law expression, the rate of this reaction is equal to K NO2 Cl2 chlorine. The power of the nitric oxide is 2 and the power of the chlorine is 1. So the value of alpha is 2. It is same as the coefficient of the reactant NO, that is 2. A and alpha are same, that is 2, 2. Beta and small b as per the general reaction are the same, that is beta is equal to b, b is 1, beta is 1. So alpha plus beta is 2 plus 1, that is 3. So this is the example of the third order reaction. Next is one more example, a reaction between NO and O2. NO and O2, they combine, they react and they form NO2. According to rate law expression, rate is equal to K NO2 O2 1. So the order of the reaction is alpha plus beta. Here the alpha is 2, beta is 1, alpha plus beta is equal to 2 plus 1, that is 3. So this is the example of the third order reaction. So a reaction can even be of zero order. We'll write the example of the zero order reaction. zero order reaction. A reaction is said to be of zero order if it is or rate is independent of the concentration of a reacting species. तो वो रिएक्शन जिसमें रेट डिपेंड नहीं करती है द कंसंट्रेशन ऑफ द रिएक्टेंट्स, दैट इज कॉल्ड ए जीरो ऑर्डर रिएक्शन. एग्जांपल, thermal decomposition of ammonia on platinum on the surface of platinum catalyst under pressure. So when ammonia is heated on the surface of the platinum or molybdenum at 1130 Kelvin under pressure, it forms N2 plus thrice H2. The rate, according to the rate law expression, is independent of the concentration of the ammonia. So here the value of alpha plus beta is 0. So this is the example of the zero order reaction. क्योंकि यहाँ पर the rate of reaction does not depend upon the ammonia because it depends upon, it takes place only when it is heated under pressure on the surface of the catalyst. Then this ammonia decomposes and forms nitrogen and hydrogen. Number second example is photochemical reaction between H2 and Cl2. Hydrogen and chlorine, they do not react or they react very slowly, but when they are taken in presence of the light, they react and they form hydrogen chloride. So the rate does not depend upon the concentration of the hydrogen and the chlorine. The reaction only takes place when light, this is h nu, the photon of the light, falls on when the reaction takes place in presence of the light. So it has been observed experimentally that it is the example of the zero order reaction where the rate does not depend upon the concentration of the hydrogen and the chlorine. These are the example of the zero order reaction. Now a reaction can be of fractional order. Fractional order reaction. A reaction can even be of fractional order. For example, reaction between hydrogen and bromine. hydrogen and bromine, they react and they form twice HBr, and it has been observed that the rate, according to the rate law expression, the rate of this reaction is H2Br 2 raised power 1 by 2. So what is the order of the reaction? Order of this reaction is the value of the alpha, that is the power of H2, the molar concentration of the hydrogen, that is 1, and bromine is 1 by 2, that is 3 by 2 ones are 2, 3 by 2 or 1.5, or we can write 1 by 2. So it is a fractional order reaction. Or we can take second example of this, the reaction between CO and Cl2. Then the CO and the Cl2, they combine, they form COCl2. This is carbonyl chloride, and according to the rate law expression, the rate of this reaction is CO, that is 2, and Cl2, that is half. The order of the reaction is equal to 2 plus 1 by 2, that is 5 by 2, or that is 2.5, or that is 1 by 2. It has been observed experimentally, the value of the small a here is 1 and the value of alpha is 2. So the value of alpha is different from the coefficient of the reactant CO, that is 1. Here it is 2, the value of small a is 1. Here it is the value of the small b as per the general reaction is b, that is 1, and beta is 1 by 2. So 2 plus 1 by 2, that is 5 by 2. The order, it is a fractional order reaction. So this was fractional order reaction. Now rate constant of the reactions of different orders. Units of rate constants for reactions of different orders. तो हम कैसे डिटरमाइन कर सकते हैं, एंड व्हाट आर द यूनिट्स फॉर द रेट कांस्टेंट, दैट इज k, for the reactions of the different orders. So we will write a general reaction. Vb gives the product, and rate according to the rate law expression is equal to k. Here a we have alpha, and b we have beta, where alpha plus beta is equal to n is order of the reaction, जैसे कि हमने अभी डिटरमाइन किया. तो अल्फा प्लस बीटा जो है, that determines the order of the reaction. So इस जनरल रिएक्शन के जरिए से we will write the units for the rate constants. So k as per the above rate law expression is equal to rate divided by a raised power alpha b raised power beta. What is rate? Rate is the change in the concentration divided by time. The concentration divided by time, and A is molar concentration. So we can write this molar concentration, this too is molar concentration. So molar concentration raised to power alpha, molar concentration raised to power beta. So we can write concentration, bases are same, powers are added, concentration raised power alpha plus beta. But alpha plus beta determine the order of the reaction. So this is also equal to n. N denotes the order of the reaction. So rate, we can write this rate constant K is equal to concentration divided by time into 1 concentration raised power. Instead of alpha plus beta, we have alpha plus beta is equal to n. This is n. Now here concentration, इसका power क्या है? कुछ नहीं है. That means it is 1. Here concentration raised power n. In case of the division, when the bases are same, powers are subtracted. So we can write concentration raised power 1 minus n. ये डिनोमिनेटर में है, ये ऊपर ले लेंगे न्यूमरेटर में, ये माइनस एन बनेगा. डिवाइड बाय टाइम, टाइम का पावर जो है 2 is 1, so टाइम भी ऊपर ले लेंगे, so टाइम raised power minus 1. So this is the expression K is equal to concentration raised power 1 minus n, where n is the order of the reaction per time. From this we will derive the units for the rate constant. So we will write of the different reaction, order, unit of rate constant. First we will take zero order reaction. Zero order reaction. In the zero order reaction, what is the order? What is the value of alpha plus beta? That is 0. And from this we will derive the unit for the rate constant of the zero order reaction. Concentration, unit is moles per liter. Raised power 1 minus n is the order of the reaction. It is a zero order reaction, that is 1 minus 0. Into time, it is second, raised power minus 1. So 1 minus 0 is 1. It is mole per liter per second. This is the unit for the zero order reaction. Now first order reaction. In the first order reaction, what is the order of the reaction? That is 1. Now we will substitute 1 for n. So the unit will be concentration. Unit is moles per liter. Moles per liter. 1 minus, it is a first order reaction, that is 1. This is in for n, we will write this 1. So 1 minus 1, that is 0, into time. Time ka unit है second, minus raised power minus 1. So 1 minus 1 is 0. Anything raised power 0 is 1. This whole becomes 1. So this is per second. The unit of the first order reaction is always per second. Now second order reaction. For second order, the order of the reaction is 2. So here n is 2. That is mole per liter. 1 minus 2. 1 minus 2. Because n is the order of the reaction, we have order of the reaction to time per second minus 1. That is 1 minus 2, that is minus 1. So minus 1 power में ले लेंगे, mole minus 1 liter, minus 1 into minus, that is plus. So it will become liter मोल पर मोल, क्योंकि ये -1 आएगा, मोल का पावर -1 आएगा, लीटर का -1 इंटू -1 +1 आएगा, +1 की जगह हम L ही लिख सकते हैं, एंड पर सेकंड. So this is liter per mole per second. And now last, that is third order reaction. So the unit for the rate constant of the third order reaction, this is the reaction, third order reaction, the order of the reaction is 3. So for n we will substitute the value as 3 because n is the order of reaction and we are writing the unit for the third order reaction. N's value is 3. Concentration is, its unit is moles per liter, mole per liter raised power 1 minus order of the reaction is 3. Here order of the reaction was 2. Here order of the reaction was 1. Here order of the reaction was 0. So it is 1 minus 3 per second, that is equal to mole per liter raised power -2 second raised power -1. -2 से मल्टीप्लाई करेंगे तो -2 इंटू लीटर -1, दैट इज माइनस माइनस प्लस, वो L का पावर आएगा 2, मोल का आएगा -2 because here mole is 1. 1 into -2 is -2, S का -1. So the unit for the rate constant of the third order reaction is liter square mole raised power -2 per second. This is the unit for the rate constant of the third order reaction. So again from the rate law expression we have derived the units for the rate constant of different orders of the reactions. Thank you.